Hello all, it's Sumit, and in today's topic we're going to learn about k nearest neighbor. So before starting that, I'm going to give you a brief outline of what we're going to cover up in today's session. First, we're going to see what is k nearest neighbor, then distance calculation, determining the k value, how the different values of k may affect the accuracy of the model. Then we're going to see the data standardization, use case of this k nearest neighbors, and at last we're going to jump into the live coding session. We're going to see, like, based on the available data, how we can predict the person is having diabetes or not. So let's start this. What is k nearest neighbor? It's a lazy learning instance based classification algorithm used in pattern recognition. Why lazy learning? Because k-nearest neighbors stores all the available data points and that classify based on the number of value of k. Let's say it's going to store all the value, and for the value of k it will going to search the minimum distance for the available data points nearest to it. For this circle it will going to take up the 5 circle, and it will going to see like it has only 2 brown points and the 3 green points. So based on the number of classes which had got the more weight, it will going to turn itself into that particular class, let's say in this case as green. So now we're going to see like what are the different type of distance calculation we can use it for k nearest neighbor. First is the Euclidean distance and second is Manhattan distance. Euclidean distance is always the minimum straight line between 2 points, and its formula is, let's say for this graph I have given two data points like point A and point B. Point A is x1 y1 and point 2 is x2 y2. So for this point, if I have to calculate the distance between the two data points, like between A and B, so minimum distance between it would be the root over of x2 minus x1 whole square plus y2 minus y1 whole square. So this we can call as an Euclidean distance. Whereas Manhattan distance is always the distance between a 2 point which has been measured along axis at right angle. What does this mean? Let's see this diagrammatically. Let's say this is my two data points, point A and point B. So this green color which has been marked, this is the least distance between it, and this least straight line we can call as an Euclidean distance. Whereas this blue color line, red and yellow color line is been always measured along axis at right angle. So you can see this, it's going in this way, this is also going at right angle, and same as for this yellow line. So the best example for this would be in the Google map. Let's say I have to travel from point A to point B. So the minimum distance or the minimum straight line between it we can call as the Euclidean distance. Whereas if you have to travel by road for calculating the distance, so this is the best way to visualize like what's the difference between Euclidean distance and Manhattan distance. Now we're going to see like how the different k values affects the error rate, or let's say accuracy of the model. So basically like different k values can have direct impact on the accuracy as well as determining the feature for the new data points. Let's say in this example, if my k value is 5, so for the least 5 data points which are nearest to it, so in that circle majority of the colors are in green and the two are in red. So in this case where the k would be 5, so in that case this data point will going to consider itself as green. Whereas if I am taking the k as 7, so when the k would be 7, the nearest possible data point which are nearest to it, so in that case it would be the circle, the radius would be bigger. So in that case the 7 nearest data points which are nearest to this data point, so the brown color are in majority of it. So in that case this data point will need to consider itself as 7. So let me explain you like how outliners or the distorted data set can have direct impact on the k value for this KNN model. Let's say I'm taking up this example. So in this graph there are different data points available which are being segmented across one kind of, it's been segmented across one point or one area, you can say. Now if we have an outliners, let's say I have different data points, the different brown points which are available little bit outside. Let's say it's forming the different cluster there. I'm going to take the different panel as green something. Okay, yeah. So now let's say for this I'm taking the, now I'm going to take the, let's say I'm taking this as okay, this will be visible. Let's say for I have to determine this pink color new data point which has been available here. So for this point, if I have to take the nearest five which are available to it. So 1, 2, 3, let's say this is a graph. So this is a small 1, 2, this is nearest, this is nearest, this is nearest. So let's say I am making something like this. So in the nearest of it, so in my this radius, the nearest data points which are available here are 1, 2, 3, 4. So out of this 4, green are in majority. So it will always consider this point like 1, 1, 2, 3. So these are in majority. So in the nearest for the given k as let's say 1 2 3 1 2 3 4, for the given as 4. So for the k value as 4, the nearest data points which are available to it is 1 2 3 4, and the majority are in green. So in this case, the new data point, the prediction would be always be green. It will going to identify that as in this class. If my data points lies somewhere, it lies somewhere around here, and here I have to make a prediction based on let's say as k as let's say as 2 or something. Yeah, if I'm taking as 2, so if I'm to take this as 2, if I'm going to make the circle here, you can see like here the green color data points are nowhere across this, and these are the mostly the outliner, or you can see as the distorted data set. So based on this, if I have to identify the new data set, so it will going to always take as 1 2, and these are in majority. So for this new data point which I have to predict, in this brown color and majority, and it always going to predict based on this brown color, so it will going to be brown. So this is how, like, this is based on the outliners, or you can say as a distorted data set, where out of this one cluster, if you are forming a different cluster somewhere else in the graph, then you can easily see that, and you can visualize to see how it can have direct impact on your data set, and how it can have direct impact on your the k value, and this k value will going to definitely affect the accuracy of your model. So now if suppose you have understood this, we're going to see this kind of data standardization to avoid that problem like what we had faced, like the different outliners what we had seen here. If suppose different outliners are there, to avoid this kind of issue, there's a technique called data standardization. So now in data standardization, we're going to see like it's kind of a scaling technique where the values have been centered around the mean with unit standard deviation. This means that the mean of the attribute becomes 0, and the resultant distribution has some kind of unit standard deviation. So let's understand this diagrammatically. Let's say one of the feature, like, so let's say these are my different feature which have been plotted using the box plot Seaborn, and it been visualized in the way like this one of my features lies in the range. Let, let's say from this range from 10 to 20, this lies between is kind of less than 0, let's say negative. This is around from 99 or 95 to 180 or something, and this round. So you can see a large kind of deviation between these two columns, like this lies in negative, this lies around more than 90 plus, this lies between from 0 to less than 50 or less than 25, and this lies and very less than that. To solve this problem statement, to make this data standardized, so we always have to do kind of scaling for our data, which will be always been centered around the mean value, and those mean value what we've been centered around, so on that basis we're going to standardize our data to feed it to our model. So this is what we call as data standardization. So now let's move ahead, and now we're going to see the different use case of k nearest neighbor. So there are very different use case for the k nearest neighbor, and in practical where it can be used as. So first is like the Netflix shows recommendation. So for example, if you watch any show on any kind of OTT platform, there you will going to see like based on the movie what you had seen. Like let's say for this example, you have seen Narcos. So based on the kind of genre type, like what movie that particular characteristics belong to, or the text is belong to. Let's say you had watched the Narcos, so based on like Escobar, criminal, it will going to predict you, or it will going to recommended you the new movies to watch. In our e-commerce as well, so e-commerce always show you the recommended products based on the your buy order, your search history. So based on this, e-commerce website always recommended you the products, whereas it been used in for search text recommendation. Let's say in Google you type something and by mistake you did some kind of typo error, so in that case Google always suggests you like did you mean this, or it will going to give you the correct format of it with spelling. So there we can see this use case for this k nearest neighbor. And the third thing where it been widely used is for OCR. So OCR is for optical character recognition, where kind of if you have seen this Google Translate, where if you just translate anything or you're going to see, so it been used for this OCR. So these are the main widely used real world application for this k nearest neighbor. Okay, so after understanding theoretically and mathematically, like what is k nearest neighbor and what are the different use case of it, we will going to jump into our last part of this, like the coding session, where we're going to see the generic code template where we're going to predict the person is having diabetes or not. So this would be the kind of generic code template where it can be applied on any KNN algorithm. So there are the different steps involved. What we're going to see is like first we're going to see if we have any kind of distorted or outliner data set. So in that case, how we're going to handle our data. So in that we're going to see how we can standardize the variable. Then we're going to split our data. So based on the split data, we're going to create our KNN model. Then we're going to predict on it. And then at last, we're going to do the evaluation to know the accuracy of my model. So let's start with the coding part. Okay, so before starting with the coding session, I'm going to give you a brief outline of what we're going to cover up, and like what is the kind of problem statement and what the solution we are looking for. So a problem statement is like you have been given with one data set, and in that data set all the columns have been unknown, like you have been not been provided with the column names, and you have been only provided with the target class, and based on that target class you need to predict, like, and based on all the columns, unknown columns, you have to predict like where the new data points will actually fit based on the available classes. So for this, like, and this code will like based like what are the scenarios we are doing it here. So it will going to apply for all kind of generic k nearest neighbor algorithms. So first what we're going to do is we're going to do the import libraries. So first we're going to import all the libraries. Once I got imported all the libraries, then I'll going to kind of read the data. So this is my classified data, it's my local folder. So first I'm going to read it. So before reading it, so I have to make this as index as, so I'm going to explain you the use of it. So when I'm going to read it nominally without doing that, so once I'm going to print the, so once I'm reading it, I'm storing that in one data frame, that is a df. So when I'm going to do as a df.head, so once it got printed, you may see like there's a kind of extra column and it's been named as unnamed 0, and it stores kind of unique or the sequential number of all the number of rows which are present, and there's a already one column which states about the number of the sequential number of the rows. To avoid that, what we're going to do, we're going to set the column statement, or you can copy this and you can set as index column as 0. So in this case, if you are setting the index column as 0, it's going to start reading it from here. So in this case, we're going to print it. So now you can see that index column is gone, so it's not there anymore, and it will going to we start from this point, and this will be the kind of the sequential number for the number of rows. So once you will going to read it, so after doing df.head, what you're going to say is your data with the number of columns has been something kind of weird columns, let's say as WTT, PTI, EQW, and one with the target class. So here you are only been known with the target class, and rest all the column name has been hidden. So you are not aware of this. And based on all these classes, let's say you can call as feature, you need to predict the new data points, like in which class it belongs to. And our target classes are of two types, whether it would be 1 or 0, that is in discrete value. So once reading this data, you may see like this data varies like 0.9139. This is near to 1, and this is more than 1, 1.16. This is like half of 1.56, 0.755, 1.5, 0.92. So data lies around like less than 1.6. No, we have 1.23 as well. So the max you can say 1.5 as well. So data lies around 1.5 to 2.5 you can say. So that lies around that range. So once you will to do this df.head, now seeing this, like there has been variance in the kind of, there's a more deviation in the kind of data which is present. So I'd explained you about standardizing the data. So kind of we're going to scale up the data for that, because Cannon classifier predict the classes of the given test observation by identifying the observation which are nearest to it, and the scale of the variable matters because it do affects the accuracy of your model. So for that, like we're going to have from sklearn, we're going to import this library standard scaler. Let's execute this. Yeah. So once we're going to execute this, we're going to create the object of it and a scalar. Once I'm going to create the object of it, we're going to try to fit in. So before fitting it, so I'm going to drop my target class. Why I'm going to drop my target class? Because this is my dependent variable, and the axis I'm applying as 1, because this I'm applying across column. So I'm applying axis as 1 and I'm dropping the target class, and I'm going to try to fit it. So once my fitting is done, I'm going to try to transform it. So once fitting is done, and when I'm trying to transform it, so there also while transforming, I'm just from my data frame, which is my original data frame, where I read all the entire data from this classified data. From there I'm just dropping the target class, which is my dependent class, and I'm applying the same as axis equals to 1 to apply across the column. So here also, once I'm doing the transform it, I'm going to print it. So on printing, you may see like this scaled feature which I got the object, like in this I got the scaled features. So in this is kind of raw data, and this raw data is in array. So this is array of is in kind of array data. So in this array data is, this is like without column name. So to apply the column name, now we have to assign with the column name. Now we're going to see like, if suppose if we are doing this df dot column from this 1 is to 1. So once you're going to see, you can print in this way, you can print all the column names. Now we don't need this target class because in this array of data we had dropped this target class. We haven't used because this was our dependent variable. So here also we have to exclude this. To exclude this, we can, while reading, so this will going to read the entire column. So to avoid that, we're going to do pass as -1 here. So on doing that, you may notice that this target class will not be been considered. Yeah, so this class has been excluded. So this concept why I explained, because in the next, when I'm going to read the data frame from this scale feature and I'm going to apply the column to it, so now I have got like from this df dot columns, I have got all the column names, and this I have got the array of data. So for this array of data I need to apply all the column names. So to do that, I'm going to do pd.data frame, and this for the scale feature I'm going to do pass the raw data, which is this is the array of data. As a scaled feature, I'm going to pass it, and the next argument would be columns, and that would be df.column as -1. So this will going to exclude the last target class. So once this is done, I'm going to do df.head, df_feed.head to know like how my data got arranged. Yeah, so here you can see I don't have my target class, so my target class had got excluded and all the data had got standardized. So in previously you would have seen for this, let's say for the first column, so data was starting with kind of 0.9139, and it was like for nxj it was like 1.23. Now it is like minus 0.12352, and it is minus 0. So this data had got scaled. Now we can use this data for our KNN model, because like I had already explained you in the theory wise, because this is going to have a direct impact on the accuracy of the model, and it will going to affect as there are more number of outliner, it will going to affect the new data set which you are about to predict it. So once I'm done with the standardization of data, so once that is done, I'm going to do data split. For data split from this sklearn library, I'm going to import 10 test split. So on doing that, you can actually go into it. You can do shift tab, and you can enlarge this to see like what kind of documentation for this API, like how this has to be used. So this on this way you can use it. So you can see this example here. Random size is 30. You can put the random state as well. In my case, as of now, I didn't put it. If you want, I can put the random state as just a second. Yeah. So I can put my random state. I'm just going to copy this. I'm going to paste it here. Random status 101. So you can put any number, but if you're going to put 101, it will going to have the same result in your system as of mine while doing this. So I'm putting the test size as 0.3. So in this would be on 70% data I would be training my model, and the rest 30 I would be testing with. So this is my test size, this is my random state, this is my scaled feature, and this is like my x, and this is my y. Y would be always my dependent class. Let's say my dependent variables, this is my dependent column as a target class, so which I am being passing here xy. So based on this, I'm going to split my 10 test data split I would be doing here. So let's execute this. Yeah, so once this is done, we're going to go ahead and we're going to create a KNN model. So for that, from sklearn, we're going to import k nearest neighbor classifier. So while importing this, I'm going to create the object of it. To create the object of it, so In this, I have passed the parameter as n neighbor as 1 and metric as Euclidean. So why I am passing the metric as Euclidean? Because the default would be something else which would be quite similar to this Euclidean, but as I already explained you during my theory session, we can use either we can go with a Euclidean or you can go with a Manhattan, like whichever suits you based on the requirement. In my case, I am taking the metric as Euclidean. This n neighbors, this says about the number of k, the nearest k value, the number of k value which we had to take it up. So in my case, as of now, for this I am putting with the 1. Later on, moving ahead, we're going to see like how that in different values of k, it will going to affect the accuracy of our model. So on executing this, we're going to create the object of it with k as 1. So I'm going to fit my train data to it. So once that is done, I'm going to predict on that. So when my prediction is that, I'm going to print the prediction. So this is my prediction. So I'd already predicted it based on my train data. So when my prediction is done, the next would be evaluation. So on evaluating, I would be having the three parts like I had already explained as before, that a classification report, confusion matrix and accuracy score. To know in detail about all these three, you can see my previous video about the logistic regression where I already explained about three different kind of evaluation. So in this, using the sklearn matrices, I am going to import this classification report, confusion metric and accuracy score. Once I am going to import it, I am going to print the confusion matrix. In my case, it's a 2 by 2 matrix. Why 2 by 2 matrix? Because my target class is having discrete values that is in 0 and 1. So here also you can see what is the prediction it had happened, that is on 0 and 1. That clearly say that is the kind of categorical feature. So it's always holds kind of 2 by 2 matrix. This can be large in the case scenario like where you have the number of classes would be more, like you have to predict more than two classes. So in that case, your metric will going to confusion metric dimension will going to get large. So the for this confusion matrix, the number of like the number of values present diagonally would be more. It would be more good for your accuracy. So in my case, we can see 151, 126. So to get the accuracy of it manually, what we can do is we can sum of all the values in diagonal, then divided by total number of cell values, like 150, like 151 plus 126, which are the values present diagonally, by 151 plus 8 plus 15 plus 126, which would be equals to 0.89 something. So the next would be the kind of classification report where you will want to pass the white test which we had got from our uh, split data, white test and the predicted value. Based on this classification report, you may going to get your precision, recall, F1 score and support. So in my case, I am getting the accuracy about 0.92, recall as 0.92, F1 score as this, so which is kind of good. At last, I'm going to print my accuracy score. So that is around 0.92. So now you have seen like these are the three different kinds of evaluation we had used to predict the value of my model. Like let's say the accuracy of my model. In this case, what is the model I had created? I had created the model with k as 1. My n neighbors was 1. So in the case which I had already told you, like the different values of k will going to affect the accuracy of your model. Now the next part would be we would be visualizing like how with the different values of k, if you're going to increase the value of the k, let's say from 1 to the larger number, in that case how our accuracy will going to get. Okay, so now once we are done with evaluating our model, let's say with the three different types of classification report, confusion matrix and the accuracy score, we're going to go ahead and going to see like how choosing the different k value will going to affect your accuracy of your model. As of now in this example, we are did only with n neighbors as 1. So in this case we have taken the k as 1. So what if as I told you in my previous example or in my previous slides, like the different k values will going to affect the accuracy of your model. The larger the k value, the good will be the accuracy of your model. So because k nearest neighbor has a habit of manipulating with all the data, and it will going to predict based on the number of k values which have been inputted and kind of creating an instance of this model. So in this case we have taken the k as 1. Now we're going to see like how with the different k values we're going to visualize and see with the different k values in this case how it will going to be as. So for that, first what we're going to do is we're going to create one list, let's say in my case as an error rate. So this is my list. So in this list I'm going to run a loop, let's say for I is in range 1 to 45. 45 is the number of the key value. It could be different in your case based on your data set. Based on my data set, as of now I'm taking as from 1 to 45. Then these three steps are quite similar. We are just creating the instance of it, and the neighbors which the k values. So this parameter and neighbors is my k value. So this k value I am assigning as 1 or I am assigning as I. So what would be for the different like in a loop for the different values from 1 to 45, it will going to create a different object of it from 1 to 45, and it will going to store in KNN. So once that KNN is done, I'm going to fit based on my train data, then I'm going to predict based on my test data, and whatever the prediction I got, I'm going to store in one variable predict underscore I, which I would be seeing like based on the which shouldn't be equal to the y test, and taking the numpy mean of it, I'm going to add it to my error rate which I had created the list, for which we're going to use it for plotting and visualizing the data. So once this is done, I'm going to execute this 1 to 45. It may take some time, but based on a data set, it will going to differ. So my this part got executed. Now I'm going to go ahead and I'm going to print my error rate. So on my printing the error rate, you would have seen like I have got all my data here, like my error rates, like how my error rates have been varying. So this is in my list, but the thing is this is my list, I am not able to visualize it more properly. So for that, what I'm going to do is I'm using the plotly, which I had already taken using the matplotlib as the pyplot. So using this matplotlib, I'm going to visualize this. So for that, what I'm going to do is I'm going to set the figure as fixed size as 10 by 6. This is 10 by 6. You can set anything you want based on your requirement. Then in the plot, I'm the x data which I'm passing, this I'm passing in the range 1 to 5 or 1 to 45. So this is my k value which I have taken here, 1 to 45, which I'm about to plot. So this I would be plotting across the x axis. So this in my x axis, the k value I would be plotting from 1 to 45, from 1 to 45. So this is my 45, and the error rate and the y value which I am passing as the error rate. So whichever the error rate which I had obtained from this, which I had stored in this list, so this list I am passing as my y value. This color I am setting as red, line style as dashed, marker as asterisk, and the marker face color as red. You can do shift tab on this. You can click on this function and you can do shift tab to see the entire documentation of it, and inside that you can see how the parameter can be used with the different examples. So you can explore up this part. So once this is done, I'm going to set the title of it, that is error versus k value. So by this we're going to set the title and the x label and the y label. So once this is done, I'm going to execute this once again. So on executing it, I'm going to get a graph like this. So here we can clearly see on value as k as 1, the error rate had been gradually increased and it had been sharply decreased after that. So when the k was around near to, let's say, as 3 or 2.5 or 3, so in that case it had decreased, or you can say for the k value as 2 it had decreased, or for the k value 3 then it had again increased, then it had decreased, and at last for the k value as 40 it has been very minimum. My error rate is less than 0.5, which has been considered very good. So less than 0.05, it has been less than that, and this we will not consider this 3 point, otherwise it would be kind of overfitting the model. So for this, like for the k value as 40, so by this graph you can clearly see when my k value is 40, my error rate is very less. When the k value is 2, my error rate is very high, that is around 0.09. Now using this three, again the evaluation parameter, let's say classification report, confusion metric, or the accuracy score, you can actually go and see like what's the prediction of it. Now we're going to do a quick comparison between the 2 points. Let's say the first one I'm taking as 2, so in that case I'm setting the k as 2, the nearest neighbor I'm setting as 2, and in that case on this I'm going to predict it. So I'm predicting with this, what I've got when I'm predicting with KS2, I'm getting a confusion matrix 154 119, and the mislabel parameters are 5 and 22, and my accuracy is at around 0.92. It's been good, but it's not that good. Now I'm going to compare the same where the K was 2. So now I'm going to compare the same with k as 40. So in this I'm going to pass my k value as 40. Based on that I'm going to actually fit and predict, and I'm going to print the confusion matrix and the classification report when executing this. So now you can see the mislabel parameter in my confusion matrix are 5 and 7, and my label parameters are 154 and 134, which is quite good at compared to this. So here in this case the mislabel parameters were 5 and 22, but in this case it is around 5 and 7, and my accuracy had already improved here. So you can compare the accuracy. Previously it was around 0.92, now it is 0.96. So the accuracy of my model had gradually increased when I have set the k value as 40. So as I had already told you, like this k nearest neighbor is always performs good on very last data set, and where you are setting the k value as greater. The more the value of k, the good the accuracy of your model is, because it helps you more to understand the feature and you're going to predict based on that. So this way we had compared like how we can visualize with the different k values, and how we can see the comparison report, and how we can see the accuracy of it. So by this we had completed this use case. So this use case you can, where if you are if you are given with the data set with kind of unknown columns and with a target class, and you can use this kind of a steps, like what are the steps I had explained, you can use this, and this will be act as a kind of generic code template for you guys to do in other exploratory projects if you want to take up for this k nearest neighbor. So you can do this part. So I hope I had made myself very clear about the this k nearest neighbor, its algo implementation, and the real world use case. So next what I would be doing, I would be coming up with the more interesting machine learning videos. So for that please do like, share and subscribe my YouTube channel, and hit the bell notification icon to stay updated. Till then, have a great day. Thank you all.